In this video, we're really going to look at how do we restrict the domain. And we can restrict the domain simply by saying, I am restricting the domain. So when we say how, we're really saying, where are we restricting the domain? But then we're also going to talk about how that impacts the domain and range of what we end up inverting and the domain and range of the inverse that we get. So this is the one that we looked at on the Desmos exploration. My graph was red when I did it then, but it's green now. But it's the same graph. I know that in general, I should actually have a function that looks like such. But we restricted the domain. We got rid of this portion. We erased it. We said goodbye. But mathematically, I have to be able to write that out somewhere. So my restricted domain, so after I cut this half off, the domain that I have left now, well, it starts at where the vertex was. And I can see from here, oops, that is a typo in my PowerPoint. This was x plus 1 squared. I can see here that my vertex is at -1, 0, because I actually have a plus 0 hanging out on the other side. So I can see that the x value where my domain starts is the x value of that vertex. So I can say that my domain is from -1, and then it's going to keep going to the right. We know that quadratics keep going on forever, and we didn't cut anything on this side. We cut the left-hand side off. We're saying, hey, we're only going to start at that vertex, and then we're going to keep going on forever. We can also look at the range. Interestingly, the range doesn't change when we cut the domain off because we're starting at what was the lowest point. Well, my lowest y value is 0, if I take this over here, and that 0 came from my vertex as well. So my range would be from 0 to infinity. Now, what we know from inverses is that this domain, because all I inverted was this part to create this inverse, that my domain here should be the range of my inverse. I'm going to go ahead and write it there, and then we're going to check and see if it works. I also know that what was my range of my original function, just the part that I inverted, should be the domain of my inverse. So once again, I'm going to go ahead and write it here, and then we're going to see, did that work? So if I'm now focusing in on my inverse, and this is the correct equation here, we can still do vertex form. This is really an x plus 0 on the inside minus 1. -0 is just 0. My y value to the outside is -1. And I can see that is my inverse. Or sorry, my vertex. So my domain, we're saying should start at x equals 0. Well, sure enough, when I'm here, where I start, this is on the y-axis, which is where x equals 0, and I'm going to the right, so I'm going to infinity. Okay, that worked. Well, then it says our range should be -1. Well, once again, this is where I'm starting. That is my lowest point, and sure enough, yeah, the y is -1, and it's going up slowly, but it is going up, so it's going up to infinity. So we did, in fact, see that after we restricted it, the domain became the range, and the range became the domain. But once again, one of the key parts here, especially when we're talking about quadratics, is this is the restricted domain. The restricted domain becomes the range. The other way you'll often see this talked about is the invertible domain. When we're saying the invertible domain, we're just saying, where are you restricting the domain so that we can invert it? And once again, it's everything the same. We're talking about this vertex.